Good evening, everyone. My name is Harry Kominos. I'm an OpenStack engineer at ECMWF. And in this very short keynote, I will very quickly try to present to you what ECMWF really is as an entity, what is our mission, what is our goal. And I will also present how OpenInfra helps ECMWF achieve these goals. So ECMWF really stands for the European Center for Medium-Range Weather Forecasts. We're an intergovernmental organization founded in 1975. And it's primarily funded and guided by our member states. We are currently located in 3 sites, our Reading headquarters, our EU office, and our Bologna-based data center. And our mission is to produce numerical weather forecasts and monitor the Earth system, meteorology. So weather forecasting is extremely complex. Okay, there's an issue with the slides. Anyway. So every day, the center receives nearly 800 million observations from a natural environment, with the ultimate goal to create a detailed snapshot of the Earth's weather. Those include temperature, precipitation, wind, and many, many others. There are multiple systems around the globe that provides this measurement to us. Our initial goal is to acquisition or to acquire all these measurements. These are then taken, manipulated, and then provided as input into our HPC system, which then provides the weather forecast that we then disseminate to our member states. We also store many of these observations. We currently have a tape archive, which is now 1.5 exabytes in size, and every day we're adding to it about 800 terabytes of data. So for a very long time, we have been an HPC facility and a data archive facility of meteorological and hydrological data. So starting in 2019, the center decided to investigate OpenStack as a technology to help with its mission and improve upon the offering. It has been a very complicated journey that we have also presented in a previous summit in Berlin. But very briefly, we started in 2019 with Aroki-based infrastructure. We are in England. In 2022, we migrated that infrastructure in Bologna in our data center. We declared it operational. And today, we are in 2025. We currently operate 2 Caracal-based OpenStack clouds, which power around 2,000 VMs. So for this talk today, how does OpenStack help us in this journey? I have selected 3 projects that perhaps can give a very quick overview of how researchers and users use our OpenStack infrastructure. I have selected the data stores project. I have selected that is a data access platform. I have selected the Anemoi framework. That's our relatively new system in between our HPC and OpenStack. And I've also selected the forecast in our box project, also very new, and it's an ML dissemination method. So what are the data stores? The data stores are an important project by the European Commission, which was launched in 2017. At its core, it's a data access platform where we take huge amounts of data that we store in our archive and other systems, and then we transmit a subset of this data to the users. How are we able to do that? OpenInfra. There is a large number of OpenStack VMs and Kubernetes control containers whose sole purpose is to create a singular platform to fetch data from all the archives, filter it, manipulate it, and send it around the world. The platform is very successful, and every day we serve over 90 terabytes of data to users around the world, more than 4,500 users from more than 175 cataloged records. The data stores comprise of 3 separate services. The climate data store, which provides hourly estimates of a large number of atmospheric, land, and oceanic climate variables. The atmospheric data store, which serves information about the atmosphere, like pollutants, CO2, and so on. And the emergency management service, which serves information about fires, floods, and so on. The platform is open to everybody, and I would encourage everybody to explore it. Moving on, a nice, interesting project is the Anemoi project. In 2022, the center really started pursuing its AI goals more aggressively, and the result of all this effort was AIFS, AI Forecasting System. Anemoi builds on top of these developments, generalizing what started as the AIFS codebase to allow wider functionality for a greater set of users. But what really is it? At its core, it's a set of Python packages that allow users to dive deeper into this AI-based forecasting. Anemoi training, for example, contains miscellaneous tools for training data-driven weather forecasts. Anemoi models contains all the core model components that build the architecture of its data-driven model, and many others. But Anemoi is not just a technical framework. It's a philosophy of open collaboration. The code is freely available on GitHub under a permissive license, meaning everybody can contribute to its development and its activities. How does it work? OpenStack assisted. The training part is done on the HPC infrastructure, but the inference part can be run on OpenStack. The catalog is deployed on OpenStack. The datasets are served through OpenStack. So it's standing in between our HPC infrastructure and our OpenStack cloud with great success. It's a highly versatile platform where models, datasets, and variables can be tried. However, there are other projects. If we're looking for something more ready to run, we already seen how can we leverage OpenStack to run on-demand, data-driven weather forecasts, and the forecast in a box is one of our latest, although still highly experimental. Since the inference part can now be run on a single GPU, we can now send the model and not rely on sending a huge amount of data. But what really is it? Essentially, we have packaged everything into a set of Docker containers and binaries. It's a complete forecasting system that you can use, contains all the product generation and processing capabilities. It includes catalogs of outputs and products, and it can be executed in any environment provided by the user, like a VM with a relatively large GPU, or even your laptop. It contains everything you need to know to make your product, and you can have the forecast yourself. So before concluding my presentation, I would like to present the teams that are powering the OpenStack infrastructure at ECMWF, and many of the projects that run on top of it, guys that really keep the lights on and really helps us disseminate the climate data and hopefully make a difference. This year, we were also nominated for the Super User Award, so I would like to thank everybody that supported us and voted for us. So to conclude therefore our presentation, I would like to say this. Weather matters, and through the combined effort of more than 550 members of staff, we can really make a difference in important areas like fires, flooding, and many others. We cannot control the weather, but we can prepare for it. OpenStack matters for now in meteorology, and if you have not understood anything from all the slides before, we can now focus only on one. OpenStack is here to stay in meteorology, and is helping us every day to go from something that looks like this into this. Or this. Thank you.
That's amazing to see how